Assalamu alaikum, my dear students. I welcome you to my class of Cambridge Sciences. Today we're going to do Cambridge IGCSE Chemistry Paper 4, Specimen Paper 2023. We have already uploaded part 1 of this video, in which we did question number 1 and 2, and most probably we are going to do in this video question number 3 and 4. Right, so without wasting our time, let us start from question number 3. So copper is a transition element. It has variable oxidation states, which is one of the chemical properties of transition elements, right? So state two other chemical properties of transition elements which make them different from group 1 elements, right? So we have to write two chemical properties apart from the variable oxidation states. We can write they form colored compounds, or their ions in aqueous solutions, they are colored. Okay, so they are also used in different chemical reactions as catalysts, right? So they alone, or their compounds, they are used as catalyst. Moving on, part B, when copper 2 oxide is heated at 800 degrees Celsius, it undergoes the reaction shown by the equation. So this is the equation where copper 2 oxide is changing into copper 1 oxide, right? So identify the changes in oxidation numbers of copper and oxygen in this reaction, right? Explain in terms of changes in oxidation numbers why this is a redox reaction. As we all know that redox reaction is a chemical reaction in which reduction and oxidation reactions take place simultaneously. So let us see what is the change we can find in oxidation states of copper and oxygen. So look at this copper oxide. So valency number or charge on oxygen is -2. So as this is a neutral compound, so copper must be having 2 plus. So copper was having 2 plus charge, or +2 charge, before the reaction. Now coming to this copper 1 oxide, you can say that 2 minus, and there is a ratio of 2:1 between copper and oxygen. So two coppers, or two atoms of copper, they must be equalizing the charge of 2 minus, so each will have 1 plus 1 plus. So copper is having in copper 1 oxide +1. So change in oxidation number of copper is from 2 plus to 1 plus. So change in oxidation number of oxygen. So oxygen, as we mentioned over here, it is -2, right? And oxygen is being liberated or emitted during the reaction. So it being an element, it does not have any charge, because it is not a compound, it is an element, it does not have any charge. So from -2 to 0 is the change in oxidation number of oxygen, right? So as you can see that oxidation number is decreasing from +2 to +1. So this is said to be a reduction. Okay, so copper oxidation number decreases, so there is the reduction. So copper is being reduced, right? As far as oxygen is concerned, So you can say from minus to 0, it means there is an increase in oxidation number. So oxidation number increases, oxidation number increases. So this is oxidation, right? Moving on, B2, part B and subpart 2, calculate the volume of oxygen measured at RTP, which is formed when 1.6 gram of copper oxide reacts as shown in the equation. So 1.60 gram you are taking of copper oxide for this particular reaction, and you have to find out how many decimeter cube volume of oxygen is being produced at RTP, right? So let us take molar masses and molar volume of copper oxide and oxygen respectively. 4 into 63.5 plus oxygen 16. So this is the molar mass of copper oxide, and we will take 4 molar mass according to the balanced equation, right? And oxygen is having just 1 into, and the volume of 1 mole of any gas at RTP, it occupies 24 decimeter cube, right? So just calculate. 318 gram is producing 24 decimeter cube volume. So what is the volume of oxygen is produced when we take 1.60 gram? So 1.60 multiplied by 24 divided by 318 will be the volume of oxygen in decimeter cube. So let us 1.6 multiplied by 24 divided by 318, right? It is 0.12. 0.12. So 0.120 decimeter cube was the volume of oxygen produced when we took 1.60 gram of copper to oxide. Now part C, copper metal is obtained when scrap iron is added to aqueous copper 2 sulfate, right? The reaction between iron and aqueous copper sulfate is a displacement reaction. State why this displacement reaction takes place. So it's very simple, because iron has to displace copper if it is more. So we will see the reactivity. If iron is more reactive, so more likely it will displace copper. And if you go into the reactivity series, you find iron above copper in the reactivity series. So as iron is more reactive, right, then copper, as iron is more reactive than copper. Write a simple equation for the reaction between iron and aqueous copper 2 sulfate. So iron plus copper sulfate, in simple equation we will write symbols and formula of the species of the reaction. So as iron displaces copper to form iron sulfate, and plus copper will be separated from copper sulfate as an element. A displacement reaction is one method for obtaining copper metal from aqueous copper sulfates. Identify another method for obtaining copper metal from aqueous copper sulfate. So from aqueous copper sulfate, copper ions are attracted towards cathode, where they are reduced to form copper. So the process is electrolysis. So through electrolysis, we can separate copper from copper sulfate solution. Moving on, question number 4. Sulfuric acid has many uses. Sulfuric acid is a strong acid. Define the term acid. A substance that gives out H ion. Okay, so a substance which donates, which gives out, right, H ion. So H ion is said to be proton. So we can call, or we can say, that proton donors are acids, right? Aqueous solution. Define the term a strong acid. So a strong acid is the acid in which all the particles, they are dissociated, they are broken down into proton, H ion, and the negative ion. So we can say that a strong acid is an acid that dissociates completely or ionizes completely. Dissociates completely. Okay. Dilute sulfuric acid is used to make salts known as sulfates. A method consisting of 3 steps is used to make zinc sulfate from zinc carbonate. Step 1, add an excess of zinc carbonate to 20 centimeter cube, which is the volume of acid, of 0.4 mole per decimeter cube, that is concentration of acid, until the reaction is complete. Filter the mixture, heat the filtrate until a saturated solution forms, and then allow it to crystallize. So just 2 observations which show that the reaction is complete in step 1. So when the reaction completes, we will see that the excess of zinc carbonate will start settling at the bottom of the container, right? So you can write the excess of zinc carbonate settles at the bottom. Since zinc carbonate produces carbon dioxide when it reacts with sulfuric acid, so obviously carbon dioxide is observed as fizzing. So when reaction completes, obviously fizzing will stop. So this will be our second observation in this particular reaction. Okay. State why it is important to add an excess of zinc carbonate in step 1. For completing the reaction, or whatever the amount of acid you took must be used up completely. So you can write so as the acid must be used completely, which makes sure that the reaction is completed, right? Define the term saturated solution. So a solution in which no more solute can be added. In which no more solute is added. Right. If you write this phrase, you will get only 1 mark. So for getting the second mark, you have to mention that it happens at a specific temperature. At a specific temperature, because if you increase the temperature, the solubility of the solute will increase and more solute can be added. Okay. Name another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid using this method. So you can use zinc oxide and zinc hydroxide. Zinc oxide, because you are going to make a soluble salt of a zinc sulfate. So zinc oxide or zinc hydroxide. Right. Suggest why this method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid. So the only reason is that barium sulfate is a salt which is insoluble. So insoluble salts. So this method is not used for making insoluble salts. So the reason is that barium sulfate is insoluble. Now part C, in a titration, a student added 25 centimeter cube volume of 0.200 mole per decimeter cube aqueous sodium hydroxide. So it is the volume of base and it is the concentration of base, means sodium hydroxide. To a conical flask, the student then added a few drops of methyl orange to the solution in the conical flask. Dilute sulfuric acid is then added from a burette to the conical flask. The volume of dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide was, so the volume of sulfuric acid needed was 20 centimeter cube, which is the volume of acid, right? The reaction is shown by the equation. 2 moles of sodium hydroxide are reacting with 1 mole of sulfuric acid to form 1 mole of the salt sodium sulfate and 2 moles of water. State the color of methyl orange in an aqueous sodium hydroxide, as aqueous sodium hydroxide is an alkali, so the color of sodium hydroxide in alkali is yellow, whereas it gives a red color in acidic medium. Determine the concentration of dilute sulfuric acid in gram per decimeter cube using the following steps. Calculate the number of moles of aqueous sodium hydroxide added to the conical flask. So number of moles can be calculated as the product of concentration and volume, right? So the concentration of base or alkali is 0.2 and the volume is 25. 0.2 and volume is 25, but centimeter cube, so it must be in decimeter cube, so we will divide by 1000 to make the volume in decimeter cube, right? So just calculate it. 0.2 multiplied by 25 divided by 1000, so it is 0.005 mole, right? Calculate the number of moles of dilute sulfuric acid added from the burette. So as you can see, so you have to refer the equation. You can see that 2 moles of sodium hydroxide requires 1 mole of sulfuric acid. So there is a ratio of 2:1, all right, between sodium hydroxide and sulfuric acid. The ratio is 2:1. So if the number of moles practically of sodium hydroxide is 0.005, so it must be 0.0025. That should be the half of the sodium hydroxide, 0.025 mole. Calculate the concentration of dilute sulfuric acid in mole per decimeter cube, right? So concentration is the number of moles divided by the volume, right? So number of moles of sulfuric acid is 0.0025, and volume which was used or utilized during the titration process, 20 centimeter cube. So 20 divided by 1000, right? So when you calculate, zero point 0025 multiplied by 1000 divided by 20, so it is 0.125, 0.125 mole per decimeter cube. Calculate the concentration of dilute sulfuric acid now in gram per decimeter cube. So what you have to do, you have to convert only number of moles into gram. So how can we convert it? The concentration in gram, the concentration in mole multiplied by MR, right? So concentration in mole is 0.125, and the MR of sulfuric acid is 98. So just multiply by 98, so you get 12.25. Right, so hope you okay, thank you. I think you found this video beneficial or useful. So if you like this video, subscribe to the channel and share with your friends. So till the next video, take care. Allah Hafiz.